Okay, let's give you some more practice on the Venn diagram. If you don't understand, if you haven't seen this before, then watch the previous video. Okay, so here, given this Venn diagram here, this is event A, event B. Well, event B would be this long tube here, if you like. Event C would be this circle here. Event A would be this circle here. Okay, so given this Venn diagram, we'll work out the probability. It would be A and B. Okay, so this is your and A and B, and work out the probability of B. Work out the probability of B, B or C. Okay, and this one here, A and B and C, and this one not B. Okay, so press pause and have a go. Okay, so this one here. Well, let's do this one here. A and B. Well, everything inside these circles is A. Everything inside this tube is B. So A and B, it basically means the intersection of A and B. So that can only be this bit here. Okay, so that's 2. Okay, so it will be 2 over what's the total? Hang on, total would be let's merge these two. That's 10. Merge these two. That's 20. 26. Okay. So remember the hang on. Total. Let me just put this. Total equals total equals 26. Okay. Hang on. Sorry. Okay, sorry about that. So here the probability of A and B here would be just this bit here, which is 2 over 26. Okay, now the probability of B, well, just B would be everything inside here. So that would be, let's merge these two here. 2 and 8 would be 10, so it would be 13. 13 over 26. Okay, now probability of this one here, probability of B or C. Well, B or C, well, this is anything, well, if you're here, it's good because it's B or C. B or C, well, and anyway, B or C would be the union of the two. So it would be all these here. Okay, the union of the two. So B or C. Let's merge these two together. That's 10. And well, it's going to be 17. Okay, so B or C would be 17 over 26. Okay, this one here, A and B and C. So you've got to find somewhere in this diagram where it's well, if you look at this one here, it's in B, but it's not in A and it's not in C. If you take this bit here, it's in B and it's in C, but it's not in A. You've got to find somewhere where it's A and B and C. Well, in this diagram here, there's nowhere, so it's going to be 0 over 26. Okay, and the last one, not B. Well, anything inside this tube here is B. Well, not B would be everything outside that tube. So everything outside of that tube would be all these here. Hang on, would be everything on the outside. Okay, so everything on the outside would be this, this, and this. So merge these two together. That's 10. 10 plus 3 here would be 13 over over 26. Okay. By the way, the C here is C and A are mutually exclusive. Okay, because they don't overlap, so they're mutually exclusive. Anyway, this next one here. So this is A and this is B. What is the probability of A and B? And then this question here, what is the probability of A or B? And the last one, probability of not A and not B. So press pause and have a go. So here, probability of A and B. So you've got to find somewhere where it's in A and it's in B. Well, if you're here, you're in A, but you're not in B. If you're here, well, there's no one out here because this is 0. This one here, you're in B, but you're not in A. So the probability of you of A and B is actually 0, because that's 0 out of 52. Okay. Well, here probability of A or B. Well, A or B. Well, that's going to be 52 out of 52. Because if you come from here, then that's A, because it's saying A or B, so it would be a good outcome. This one here is A or B, it's in B, so it's going to be a good outcome. And there's nothing out here, so it's going to be 52 out of 52, which is 1. So it's definitely going to happen. Okay. Now probability of not A and not B. Well, not A and not B would be everything on the outside of the two circles. So that would be this number here, 0. So it would be 0 out of 52, which is 0. Okay. By the way, this Venn diagram here represents your playing cards. So this could represent red. So there are 26 red cards and 26. This here would be black. 26 black cards. So it's like me asking you A and B. So it's like me asking you pick out one card where it's both red and black. Well, how is that possible? If you pick out one card, it's got to be red or black. It can't be red and black. So that would be 0. Here it's me asking you pick out if I pick out one card, what is the probability of that card being red or a black? Well, that's going to be 1, because if you pick out a card, it's got to be red or black. Okay, and then this last question is like me asking you pick out one card. What is the probability of it not being red and not being black? Well, that's going to be 0, because, well, how is that possible? So anyway, this here is 0. Okay, so this Venn diagram here represents your playing cards, if you like. Okay, this one here. What is the probability of A and C but not B? Okay, think about it. This one here, it would be B and C. This one here, B but not C, and here A and B and C. Okay, well, do whatever you have to do. Press pause and have a go. Okay, A and C. Let's just look at A and C. A and C means the intersection of the two. Here, it would be this bit here. It's in A and it's in C. But the second part is but not B. So not B. This bit here is in B. So really, you're only interested in this 5. So it would be 5 over 36. Okay. Okay. This second one, B and C. Well, B and C would be the intersection of the two. So it would be this. So you're interested in 7 and 6. So that's 13 over 36. Okay. Oh, by the way, simplify whenever possible, if you can. Okay. This one here, probability of B but not C. Well, B, anything inside here is B, but you don't want C. Well, C, well, this bit here is C, so you've got to get rid of this bit here. You don't want. Hang on, let me illustrate it properly. So here, B, anything inside this circle here is going to be B. But the thing is, you don't want C, so you've got to get rid of this bit here. So what's left would be this bit and this, which happens to be, which happens to be this and this. So that would be 4. So it would be 4 over 36. Okay, probability of B but not C. Alright, this last one here. What probability of A and B and C? So you've got to look somewhere on this diagram where it's in A and it's in B and it's in C. If you look at this here, it's in A and it's in B, but it's not actually in C. So this is a bad outcome. If you look at this here, it's not in A, it's not in B, not in C. Bad outcome. If you look at this one here, it's in C, but it's not in A, it's not in B. You want somewhere where it's in all three. So this is a bad outcome. Bad, bad, bad. Well, if you look at this this middle bit here, that's in A, and it's in B, and it's in C. So all you're interested in is this 7 here. So the answer here would be 7/36. Okay?